All right, welcome back. So in this module, we're going to learn about balancing cycle time with takt time, which is an extremely important topic when transitioning to one-piece flow. So by the end of this module, you'll know how to balance cycle time and takt time, as well as how to calculate the optimal crew size for any process. All right, well, just as a quick refresher, the formula for takt time is simply the net available time per day over the customer demand per day. And as we've already mentioned before, takt time can only be calculated. It can't be measured. On the other hand, cycle time is always measured. So whenever we use the term cycle time, we're actually describing how often a part is completed by a particular process. All right, well, one of the keys to designing a process that flows smoothly is finding a way to balance the various process cycle times with the takt time. But before we talk about how to do this, let's spend a few minutes discussing why this is such an important lean activity. First, by studying the relationship between individual process cycle times and takt time, we're able to easily identify bottlenecks. And since takt time sets the pace of the process, it's crucial that no individual step take longer than takt. If a process does take longer than takt, inventory will begin to pile up in front of it, much like all these cars have piled up before the bottleneck on this California highway. Next, the information gathered from our cycle time takt time studies will help us identify the resources needed in order to meet customer demand. Lastly, we study the relationship of cycle times to takt time in order to create a smooth flow of work from one process to the next, preferably one piece at a time. All right, so to better understand how to go about balancing cycle time with takt time, let's work with an example. Here we see a process with 5 steps. In each process, we see one operator working. The cutting step has a cycle time of 120 seconds, welding 480, drilling 150, assembling 385, and finally, painting takes 270 seconds. For the sake of this example, we'll assume these cycle times are all manual cycle time, meaning the operator is needed the entire time. Finally, in this example, the customer demand is 1,580 pieces per month, which works out to a takt time of 365 seconds per piece. So, in order to meet the customer demand, this process must produce a finished product every 365 seconds, or roughly every 6 minutes. Well, to create a cycle time takt time graph, all we do is draw bars in for each process cycle time. You can do this by hand on a flip chart or use software like Microsoft Excel. We also note how many operators are working with that process. Next, we draw on a line for our takt time, which again is, in this case, is 365 seconds. And one of the most awesome benefits of this type of graph is how quickly we can spot bottlenecks, which again is a term that describes any process that takes longer than takt time. In this case, we have 2 processes over takt, weld and assembly. Also, we can see where operators are not being fully utilized as well as they could be. For example, the operator in the cutting area has a little over 100 seconds of work to do, meaning he or she has plenty of time to help someone else out. All right. Well, now that we've identified an example of a process needing some help, let's spend a few minutes discussing 4 specific steps we can follow in order to bring more balance to the situation. Well, first we must work to eliminate any unnecessary steps or activities from the process. For example, if there's something being done that adds absolutely no value to the end product, work to eliminate it. Ask yourself, does my customer care about this step? Or even better, is my customer willing to pay me for this activity? If the answer is no, this is your cue to get rid of it. Next, whenever possible, we want to combine tasks. In our example, it's obvious that the first operator working in the cutting area has plenty of time to help the welding operator. So by combining these 2 processes into one, we'll be able to bring more balance to the situation. Third, we want to rearrange the workplace in such a way as to reduce waste. For example, if an operator spends several minutes walking back and forth from his or her toolbox, we have a great opportunity to simply move the toolbox closer to the work area. Finally, we want to simplify the way we work. And one of the most common ways to accomplish this is by implementing some simple automation. Now, let me explain, as this advice can be easily misunderstood. We're not proposing you go out and buy several sophisticated robots to replace workers. Instead, to automate simply means to implement simple, often homemade solutions that will free up an operator to do more value-added activities. Well, by following these 4 steps, just about any process can be better balanced to takt time. Okay, well, whenever we're designing a new process, we must also put some serious thought into how many people should work in that area or within the cell. And due to the criticality, and in many cases the sensitivity of these decisions, it's important to be very fact-based. Luckily, we can make this a very fact-based decision by calculating what is called the optimal crew size. Well, the formula for the optimal number of people, or P, is simply the sum of the manual cycle time divided by the takt time. And you'll notice we mentioned the manual cycle time, since this is the time an operator is actually needed to do something. So let's go back to our example and work through this calculation. When we sum up all of the manual cycle times, we learn that the total manual cycle time of this process is 1,405 seconds. And since we also know that the takt time is 365 seconds, we can calculate the optimal crew size by dividing 1,405 by 365, which gives us an optimal crew size of 3.8 people. Now, since we obviously can't have 0.8 of a person, we'll likely round this up to 4. Another option, especially if the decimal point is less than 0.5, for example, if our result would have been 3.2 operators, is to find a way to reduce the overall manual cycle time a little more by further eliminating waste, so we can round down to 3 operators. As it is, this particular process was being operated with 5 people instead of 4. So, by rebalancing the work, we can actually free up an individual who'll be able to go and help another area that may be resource constrained. Another option, utilized by many companies well on their way with their lean journey, is to take this extra person and focus them on finding more opportunities for continuous improvement, or Kaizen. Now, it must be said, the last thing any organization should do is lay a worker off as a result of a lean initiative, since this, my good friends, is not lean manufacturing. Instead, it can be easily called mean manufacturing. Okay, so here's what our original process looked like. Again, we noticed that welding and assembly were over takt time, while the other 3 processes were underutilized. Well, by rebalancing the work with 4 operators instead of 5, we could easily see something that looks like this. You'll notice that all of the steps have been combined in some manner. For example, now, one operator actually does all of the cutting and begins the welding process. Then, the second operator picks up where the first left off and finishes the welding and begins some assembly. And this type of activity carries on until we have a finished product. You also notice that each step now functions below takt time. So here's another view of what happened. Ultimately, what we did was redesign a process to flow one piece at a time, paced to takt time. And this may be another good time for you to pause the video in order to study these graphs a bit more, in order to get a feel for what was done. Okay, well, the last thing that we'll discuss in this module is what happens when we actually add operators to a process. Here's what our original welding process looked like. We had one person doing all the work, and it took them 480 seconds of manual cycle time to produce one product. By dividing this manual work up between 2 people, we can actually cut this time in half. Now, instead of a part being produced every 480 seconds, we're able to produce a part every 240 seconds. One way of thinking about this is to remember washing dishes as a child. If you were able to convince your brother or sister to help you dry the dishes so you could focus all of your energy on washing, things would go much faster. And the exact same principle applies within our processes. All right, so now that we've covered both continuous flow as well as how to balance cycle time and takt time, it's time to focus on another key lean concept known as downstream pull. So we'll speak to you soon in the next module.